Okay, this will be the second part of the Chapter 3 AP Statistics lesson video. We're going to pick up on the next part of the notes, which is talking about bivariate data, which will be two categorical variables written in the form of a table. So this is called a contingency table. One variable is written in the rows. So the survival variable here, this is the fate of the people aboard the Titanic. And so there's a categorical variable survival, which has two categorical values, alive and dead. And so each row is about one of those conditions, right? And then there's another conditional or categorical variable called class, which is what type of person are we talking about? First class passenger, second class, third class passenger, or a crew member, right? And each number in the table gives counts, and then along the edges here, these are called the marginal totals. So they just sum up each total row or column. All right, so the variables would be class and survival, and then the values of the class variable will be first, second, third, or crew, and the values of the survival variable will be alive or dead. These numbers are not the values. These show how the data is distributed across the values. Okay. So first of all, we are sometimes asked to write out particular distributions, and we're going to have a quiz next week, and this is a big feature of that quiz, is knowing what the terminology means. So if we ask about marginal distributions, that means we're going to use only data from the margins of the table, from the totals, okay? But there are two different marginal distributions in this example. We have a marginal distribution of survival that shows how the data is distributed across the values of the survival variable. And we have a different marginal distribution of class that shows how the data is distributed across the class variable. Okay, so if we're asked to provide the marginal distribution of survival, then we have to start by listing the values of the marginal variable, which are alive and dead. And then for each variable, we want to take the value from the margin and put the count, or if we want the relative marginal distribution of survival, we would put it as a percentage. So this is the survival variable here, right? These are its values, alive and dead. And if I go to the margin, right, so 711 is the number of alive and 1490 are the total dead. So that means that we would, this right here, these numbers, alive 711, dead 1490, that's the marginal distribution of survival. So this is mainly knowing the terminology. Now, if you added those two numbers up and got that there were 2,201 people, and then figured out what percentage were alive and dead, 32% and 38 or 68%, then we would call that the relative marginal distribution, because now it's reported as a percentage relative to the total. Okay, separately, if we're talking about marginal distribution of class, right, that means, let me change color here. If we're talking about class, that's this variable. So its values are first, second, third, crew. So we have to give a value for first, second, third, and crew. We would go to the margin and say the total number in each of those categories. So this is the marginal distribution of class. And then if we wanted the relative marginal distribution of class, we would divide each of those by the total to get the percentages. Okay, so just the key though is, the way I think of it is, when you tell me to do distribution of class, I literally underline that, and then I say, whatever that is, these have to be the values that we're going to provide. So I need all the values of the class variable. Distribution of survival, we're talking about values for the values of the survival variable. Okay. We can also impose what's called conditional distribution. So a conditional distribution means we're not going to take the values in the margin. We're going to impose a condition on one of the variables and look at how it's distributed across the other variables. So like, let's say, for example, I want the conditional distribution of class. So this is a distribution of class, and that means we're going to use class variables, right? But we're not going to take the value in the margin. We're going to impose a condition. So the condition is we're only looking at the people who are alive. So then we restrict ourselves only to the people who are alive, and we look at how the data in that category, that condition, is distributed across the class variables. So 203, 118, 178, 212. So that would be that. If we wanted the relative one, we would use percentages. Okay. There's another distribution of class, conditional, because we could have imposed the condition that we're talking about the people who are dead. And then it would be just this row's values, 122, 167, 528, 673. And we would use percentages if it asked us for the relative conditional distribution of class. So you've got marginal distributions that use the totals, and you have conditional distributions that use only part of the data. Okay. Of course, we could also have done the other direction. We could have said, let's take a look at the conditional distribution of survival. That means a distribution of survival, which means we have the value alive and dead. And then we're going to impose a condition, and we want only to look at the first class passengers. So looking only at the first class passengers, how is this data distributed across the survival variable? 203 versus 128. And we could do a conditional distribution of survival for second, 118, 167, or a conditional distribution for third, 178, 528, or a conditional distribution of survival for the crew members, 212, 673. Okay? So you have to specify, and mainly getting this question right on the quiz and on the tests would be understanding how the terminology works. Okay? Okay, next thing we're going to do is have you go to the second page of the required practice packet and try problems 4 and 5. Similar questions, but with a different data set. So pause the video and then go ahead and try those, and then unpause, and we'll pick up and solve the problems. Okay, so hopefully you've done this. This is problem number 4. They gave a set of distribution here. Researchers looking at the relationship between the type of college attended and so you could either have attended a public college or a private college. That's a categorical variable for type of college, right? And then there's another variable, management level. How far did they get in their management level after 20 years after they graduated college, high, medium, or low? So another categorical variable. We don't have the totals here, right? So the first thing is it asks me for the marginal distribution of type of college. Okay, so let's do that. Well, first of all, type of college is this, and its variables are public, private. So that means I'm going to need to have values for public and private. So I will write public, private, and then I need to put a number here. It doesn't, this one says in counts and percentages, so I want to do both. So the percentage one would be the relative marginal distribution. So it says marginal, and that means I don't want to use just a particular thing. I need to use values in the margin. So I need a number here and here. So I'm going to have to add those up. And let's take a quick look. I know you know how to add. I'm not going to demonstrate that. But if you add up this column, you get 1769. And if you add up the private column, you get 1496, which gives a total of 3,265 in the table. So the marginal distribution in counts would simply be 1769, 1496. And then since we're considering out of 3,265, if I wanted the relative marginal distribution, I could take this divided by this and express that as percentage. Let me show that over here. So if I did 1676 divided by 3265, that would give me in a calculator the decimal 0.54 approximately. So I could write that as 54%, or I could write it as 0.54. So 54% of the people graduated from a public college. And then if you did the calculation 1496 out of 3265, you would get 46%. The other 46% went to private colleges. On the AP test and in all of our quizzes and tests, you never want to show a number without showing where it came from. So you would want to show this calculation somewhere on the paper, as well as just stating it. Okay? All right, and then number 5, same data, but now we want to write the conditional distribution of management level for each college type in both counts and percents. Okay, so first of all, this is a distribution of management level. Okay, so that means we have management level. So we're going to have high, medium, low. And we'll have to provide values for that. But we're supposed to do conditional, and we're supposed to do it for each college type. So that means we're going to have to do one for public and one for private. So we'll do one for public, and we'll do a separate one for private. And this is going to be high, medium, and low. Same distribution. But we're going to take the values for public, and we'll use not the margin values anymore. Like we wouldn't sum these up and use values in the margin. We'll do the conditional ones. So for the public college, this would be 75, medium is 90 and 62, and this is 732. And for private, it would be 107, 794, and 595. And then we want to do the percentages. So for us to do that, we would have to add up each of these, right? Public, we know, because we added it up before, was a total of, so this was a total of 1769, and so 1496. So I'm just going to show this. This is acceptable on my work. If you just do this, I know you're going to use that divider for all of these to find these percentages. So 75 out of this turns out to be 4%. 962 out of that turns out to be 54%. And 732 out of that turns out to be 41%. And then for the private, that added up to 1496. And so if I took 107 out of 1496, that's 7%. 794 out of that is 53%. And then 595 out of 1496 is 40%. So this whole table here labeled like this is the answer to question 5. Okay? All right. So then the next thing we want to talk about is other ways to display. So we've got the computation, right? And we can figure things out in terms of percentages and find these distributions. How do we display visually the information that's in a contingency table? Like, in other words, how could we show how the counts for public are changing from high, medium, low, and private are changing from high, medium, low visually? Okay, well, one way to do that would be to use side-by-side bar charts or pie charts, right? So you could say, for example, maybe this one would be public, and this would be private colleges using that last data, and then these things would be, you know, high, medium, and low, something like that, you know. Or you could do it this way: public, private, and maybe do this as a percentage. And then these categories would be labeled in some way. Like this would be high, medium, and low. High, medium, and low. Of course, we have more categories here, but you get the idea. You could turn these into percentages, right, using pie charts or bar graphs. Or you could use something called a segmented bar graph. So a segmented bar graph is the idea that along one of the variables, in fact, let's use the Titanic stuff. So maybe this could be first class passengers, second class passengers, third class passengers, and crew. Same thing here. Second and first. And then this could be the people that were alive and the people that were dead. This does not match the data in that table, but just to illustrate that, right? So this would be survival as a variable, and this would be the variable class, right? And then this would show the percentages. So we would have the percentages. So when we do that, like if we were to take these percentages, like percentage in each category for one thing, and make that one of these bars, and percentages for the other conditional distribution here, that's referred to as a segmented bar graph, okay? And we definitely want to be able to use that because that's very important. Last year, they updated the standards for the AP Statistics course in the summer, 2 summers ago actually, and they included this new thing called a mosaic plot. So what this shows is the same this direction, except that maybe in general, maybe there was only 25% of the people were alive in general and 75% were dead. And so what they do is they join these two bars together, but they make this worth 25% and this worth 75% of the space. So that the area, the two-dimensional area here, represents how many are in each of the subcategories in the table. Okay, so that's referred to as a mosaic plot. Okay, so this is all just different ways to picture things. Okay, so to construct those sorts of things, we would take typically conditional variables, like maybe the condition alive and condition dead, look at the conditional distribution across the other variable, and then plot those things, like for the alive category, right, the frequency in first class, second class, third class crew, and for the dead category, first class, second class, third class crew, right? And then, or it could be done with pie charts the same way, a pie chart for the alive conditional distribution and a pie chart for the dead conditional distribution. And note, whenever you do these kinds of things, you have to add what's called a legend or a key here that shows how the shading or colors tie to the categories. That's always necessary with these graphs. All right, so let's actually construct one. Let's say we wanted to take this data. We have alive data and dead data for first class, second class, third class crew on the Titanic, and we wanted to figure out how we could fill this in, right? So on your blank notes, you could fill this in with me. What we're going to do is do this with shading, since typically we just have a pencil and we don't have colors, so we just with shading. So what we could say is, okay, let's look at the conditional distribution of alive, right? And so there's 203 from first class, 118 from second, and so on, right? And this is the percentages for each of those, right? So I could start saying, okay, if this is 100% on this axis, right, this is 50%, let's say, 75%, 25%. So the first category might be the people who are in first class, and that's about 29%, so a little more than 1/4 of the way up. So I'll pick a shading, like maybe like that. And then in my answer, in my key down here, I'll just indicate that this equals first class passenger, right? All right, and then now we want to add 16.6% onto that. It's hard for me to visually see that, but if I add 16.6% to the 28% that was already there, I have a cumulative total of 45%. So I can just go to the main scale here, a little under the 50%, and then shade that and maybe call that second class passengers, right? And then if there's 25% in the third class, right? So if I add that to the 45% that was there, that's a total of 70%. So now this goes up to about 70%, maybe about there. Maybe we'll go with horizontal shading for the third class. And then for the crew, that would be the rest. So I'll use a different shading like vertical for the crew. Okay. So this is one segment of the segmented, well, this is one of the bar graphs for the segmented bar graph, the segments in the bar graph. I'm gonna have to do the same thing for the dead ones, right? The people that didn't survive. So first class passengers, only 8% were dead. So if that's 25, that's 20, that's 10. So maybe down here using the same shading, right? Second class was 11%. If you add it to the 8 that was there, it brings it up to about 19%. So maybe about here, using the second class shading. 35% of the third class passengers were dead, right? So that brings up the cumulative total to over 50%, so 54%. So that would be the horizontal shading. And then the rest would be, wow. In the people who died, the vast majority of them were crew members and then third class passengers, and very few of the first and second class passengers died. Of course, because of access to the lifeboats. All right, so that's how you construct a segmented bar graph from conditional distributions. Now, why is that important? Oh, you could do the same thing before we move on for the mosaic plot. So let's say we've got that segmented bar graph we just did, right? And we wanted to turn it into a mosaic plot. Well, what you could say is in the data, right, there were 711 total people that were alive, and there were 1,490 people that were dead. And so when you add that up, this turns out to be 34% of the total and 66%. So what you would do is go on in this category, instead of just using equal width bars, we would make this a block and devote 66% of the width to the dead and 34% to alive. And then these would be exact copies of what we just did in our segmented bar graph there. Okay. So that's how to construct these plots. I don't see the mosaic plot being used very frequently on the AP test, although it's part of the standards now, but this gets used fairly frequently. All right, so why is this important? Well, the next big idea in chapter 3, and one of the bigger ideas that we're going to see throughout the course is, are variables connected to each other in some way, or are they independent of each other? So if two variables are independent, then that means the distribution of one variable should be the same or approximately the same regardless of what the value is of the other variable. So in the Titanic example, for example, let's say we have these values of the variable. So this is the variable, let's say, let's look at this. So this is the variable survival. That's this variable. And this is the variable class down here, right? Okay. So I might want to look at, well, what is the distribution of the survival variable? Does it stay constant as I go across the values of the class variable? Well, looking at this, well, if I look at the first class passengers, a lot more than half of those survived, right? But when I go to second class, that drops to about a third. Third class and crew drop to less than a fourth. So you'd have to say that survival depends upon class, right? I think this sort of a structure where these percentages are changing, if the percentage is changing as you move across the other variable, then you would say survival depends upon class, right? Survival depends upon class because we have to know what class it is if I want to give a value. Now, if that looked different, let me just quickly draw a different scenario. Let's say that I had my variables, or my variables here. Same thing. So I've got first, second, third, and crew, and maybe my percentages looked like this. They were almost identical. So then we would say survival is independent of class, because it doesn't depend what class you're talking about. Maybe it was 52% of people survived and 48% of people died, and it doesn't depend on what class you're on, right? So really it comes down to, are these percentages staying the same, or are these percentages different? So if they're staying the same, and we say the two variables are independent. If they're different, the percentages are different, then we say they are not independent, or one depends on the other, okay? And it doesn't matter which one we decide to plot in what direction. I could have plotted alive versus dead and compared the percentages of the first class passengers to each other, and the second to the second class passengers, and the third class to the third class, and the crew members to the crew members. If it's independent, it'll be substantially different in both directions. So the question is, how close do they have to be before we would say they're close enough, okay? So there is a rule of thumb, and the rule of thumb is differences that are less than 15% are approximately equal. Now later in the course, we'll be able to state a test that's based on probability, and it's very specific to tell whether or not we can claim that these differences are statistically significant. But for our cases right now, we're going to say 15% is kind of the dividing line. Under 15%, you can say the differences are not substantial. Over 15%, you should say they are. If they're near 15%, it's kind of your judgment call. All right, so that's the idea of independence. All right, one more thing. If you need to show whether two variables are independent, you have to always consider percentages. It's never okay to consider counts, okay? And the reason for that is because, like in the case of the Titanic, there's a lot more people who were dead than alive. So if I just compared the dead numbers to the alive numbers, the dead numbers would always be higher, probably substantially higher. You have to compare percentages. That way you're comparing apples to apples, okay? And so in our course, anytime you're asked about independence, we always want you to use a segmented bar graph, because that forces you to use percentages. And that way you'll get the right answer, okay? Okay, so to finish up the lesson for today here, I'm going to have you work on the last two parts of the second page. So do number 6 and number 7. Sketch side-by-side segmented bar graphs for the two conditional distributions in number 5, and then write a few sentences summarizing what the segmented bar graphs reveal about the association in number 6. Okay, so you can pause the video, do that, and then unpause. Okay, so let's do this. Let me go ahead and grab those conditional distributions from number 5. as we did that before, right? Okay, so I'm just going to grab this here. And I'm going to put it over here. So, okay. Okay, so here were the distributions that we had. Let me use this to make a segmented bar graph. So I'm going to use 1 bar for public and 1 bar for private. And I'm going to use the method that we were using before. So the first thing you would have to do, and you're going to have to do this on the quiz next week, is I would draw, let me use black. We'll draw 2 bars like this. Okay, this axis is percentage from 0 to 100%. So 50 is around here, 75% here, 25% here. And then we'll label this. This is going to be public. This is going to be private. And then we're going to fill in the thing here. So here's what way I do it. We have to use percentages. So 4%. First of all, that's way down here. And that's versus 7% for private. So we have 4% for public, 7% for private. I'm going to use this notation for that. So this is high, people that rose to high management. Okay, medium was 54% here. If I add that to the 4% that was already there, that's 59%, which would take me up to about here. So like that. Over here, 53 added to the 7% would take me up to about 60. So almost the same. And this is the shading for medium. Okay. And for low, it's the rest. So I'll just use the other diagonal shading for low. Okay, so side-by-side segmented bar graphs for the 2 conditional distributions for number 6. This chart here would be the answer. Okay, then it says to write a few sentences summarizing what the segmented bar graphs reveal about the association. So we're specifically supposed to discuss the association. So I'm going to type this response. What we should say is something like this. The percentage for each management level is very similar between public and private colleges. Okay, so we're going to talk about why. And then in the next part, I'm going to specifically compare each one. In fact, maybe I'll just do that in the same paragraph. I'll say for high management, I want to abbreviate that, for high management level, 4% public versus 7% private. And then I'll say for medium management level, 54% public versus 53% private. And for low management level, 41% public versus 40% private. And I would say the differences between public and private are 3% or less for all categories. Therefore, this suggests that management level is independent of type of college. Okay, so this is the correct way to answer question 7. Now, I want to point out a couple things about it. First of all, it's a lot of writing. And in AP statistics, answers very frequently include explanations. The first thing we want to get used to, since this is trying to prepare you to take the AP test, is anytime we answer a question, you always have to refer to what they call the context of the question. So that's why I included phrases like management level, public and private colleges, low management level. I used throughout the whole description, I used wording from the problem. I just didn't say the data or the first data and the second data. You know, I was very specific about the context. And the second thing is that I gave the reader, just reading this paragraph, everything they needed as far as the numerical evidence to justify what I was concluding. I'm concluding it's independent, and that's based on the fact that the differences in each category are 3% or less, and I'm also providing the actual numbers for each category's comparison, so that all of the evidence that's necessary to support my conclusion is in the explanation. Okay, in AP statistics, this is required for full credit. You have to get all of that. You have to justify everything. You have to use context, okay? All right, so that's the way we would write that up. That's gonna be, I think, where we stopped for today. Yep, there's one last thing, but I'm going to put that in a third discussion, so that'll be it. You can continue to work in the practice packet just to get ready. There's more things to practice there, and then just be ready for the next lesson.